All right. Hello, everyone, for our next lecture about in systems development frameworks. After William Lyon gave us this amazing talk last week and introduced so many topics, I thought maybe it's time for a little recap about all the topics we have in the homework, because it's a little bit more complex than the previous ones. And I have for today a few slides prepared, and most of it will be the rest of the lecture will be a live demo how you can accomplish the homework, and explain a little bit about the pros and cons of each scenario or each architecture, as you wish. So let's start with the slides. That's the only theory I have for today. It's not much, but let's start. So I wasn't quite sure how it should call it. Maybe GraphQL architecture or scenarios. I stick to scenario for now. And I want to I want to give you this mental image, how you can wire up your backend with different databases or different services, and how that affects performance, maintenance, development speed, right? So just to have this in mind and be able to compare advantages or disadvantages of each. And we start basically with the architecture you would see if you would develop a traditional REST API. That was basically the situation or the motivation to start GraphQL initially. And this is what you can see here on this slide. So given you have a REST API, and this is your backend, and you implemented this backend to, I don't know, call the database and store the data there. And then you put this backend to the internet, and you have multiple endpoints, and you have your client code, which is going to call each of these endpoints in succession. Then you basically have this architecture here, right? So this is like your backend here. You're able to see my mouse, do you? Shall I paint?
Yeah, it's visible.
Oh, nice, cool. So here's your backend. This smiley here represents the client, may it be a mobile app or a browser. And these are the connections. And I painted this connection differently because this one is probably a slow connection. This is the internet connection of the client. Whereas your backend lives on the internet, and maybe the database and your backend lives on the same server, these connections are way faster than those. Does it make sense? And what's important here is that the client makes multiple requests over a slow internet connection. So this is what we have saw in the lecture where I introduced GraphQL. You maybe make a listing of all posts, and then you have to get, I don't know, the author for each post, and you make another call. So you have n+1 queries, and this is, first of all, n+1 is bad, but it's especially bad because n+1 over a slow internet connection, right? And then you start to, I don't know, overcome this problem by giving the client more data on the initial request or whatever, and then you run into overfetching and so on. So that's the problem with REST. Why not start a poll right now? Is that understandable? Like, do you remember what I was talking about? And can you remember this? Actually, messages in the public chat. Nice, cool. Yeah. So this looks okay. And when we talked about GraphQL, we improved the scenario by doing this, right? So instead of having a REST API, we have a GraphQL API. I should have labeled this GraphQL API. Yeah. Okay, next time. So this should, to make it more consistent, it should have been called GraphQL API. Apollo server is just one out of many implementations for a GraphQL API. And then you have just one complex query, one one call from the client to the backend. The backend is doing all the work to get all the data, and then it's sending one response back to the client. This is much, much better than before, because this is the slowest edge. And yeah, you have your resolvers wired up, and each resolver will call the DB. And this is perfect if you start from scratch, right? So you build a new application, then the scenario is probably the best, and you just write your own database schema and your own resolvers, and you're responsible yourself for the database. Fine. Very performant because of just one connection here. This is fairly quick. So this is probably the best, also the best performance of all, but it requires you to, start from scratch. What is actually the case for most times, especially when you start in a big company, is that you face an existing REST API. So let's say you have a big company, and this company has worked, 2-3 years on the backend. The backend has grown a lot. It's very complex, and it is built with a traditional REST API framework. Let it be Rails or whatever, and it's quite complex to refactor this, right? And it's complex also because you're changing the interface. Because you're changing the interface, you have to change both the client and the backend. So you have to do a lot of work. And what is not acceptable is that you write the backend from scratch, right? Because it will take a long time. You will put a lot of effort into code, which you cannot deploy right away. And this is not accepted for most companies. Most companies want to have put their resources into code, which will go into production quicker. I can give you one example. I was working on a donation-based product, which was a social network like last year. And we decided to go from REST to GraphQL, which was a great decision, but we made a terrible decision that we decided to migrate it in one go, right? So we were developing 2 code bases in parallel. One was the legacy, and one was the new. The new wasn't going into production, and we're spending a lot of effort and resources into the new code to refactor, or basically rewrite the architecture, the legacy technology stack. And it took us 9 months, and it was a terrible decision to do this migration. Much, much better is that you do this. So if you face an existing REST API, what you can do is you put another backend in front of it. GraphQL was actually made for this scenario. You have a backend code which is calling an existing REST API, and it's basically doing what the client was doing before, making multiple calls. That's now the responsibility of this server, right? It is possible. You can also, just in case, you can also call the REST API directly if you need. So you can step by step cover more and more REST endpoints with your GraphQL API. And this is much better performance-wise, because the connections are now, you have one end direction more, which is certainly, you could think that this is making performance worse. But since this is on a fast internet connection, it's much, much better than having n+1 here. So you basically move the n+1 problem from slow to fast connection. Maybe your backend actually also lives on the same server as your REST API. That's perfect. And there's even an officially maintained data source, REST data source. So this is the developers or maintainers of GraphQL had this scenario in mind when they published GraphQL. Does that make sense? Do you see the performance improvement and also the advantage in respect to development effort and maintenance and slow step-by-step migration towards GraphQL API? Are there, like, say no if you have questions about this, and maybe we can discuss this. This is, by the way, a nice exam question, I would say. I was thinking about like showing you a couple of diagrams in the exam and then maybe, I don't know, ask some theory questions about the pros and cons of each architecture. There's one chat message. With new code, we can then go directly to DB from Apollo. Yeah, that's up to you. You can, once you did this, right? You already have your interface in place. So there's a question in the chat. I understand this question as follows. The question is like, when we are done with this, can we then like skip this indirection here and call the database directly? And yeah, the answer is yes, of course. Most of the time you're worried about interfaces, so your front-end developers can develop on the new GraphQL interface, and the interface doesn't change anymore. And internally, you can, of course, refactor your backend or your backends to like get rid of that more and more. I'm assuming you have a lot of logic in here, so it will take some time to eliminate one endpoint after another and move this logic into the GraphQL endpoint directly. But yes, this is possible. At some point, you will end up with this scenario, probably, right? That's correct. Does it answer the question? Can you please just write me into the chat if I... Nice. So plus, cool. That was a great question. Thank you. All right. So legacy code. That's like this scenario. So GraphQL is very flexible. And this is, we are going slowly to the scenario which is mentioned in the homework. I don't know if you have heard about this trendy topic called Jam stack. Jam is short for JavaScript, API, and markup. And it's a new trend for like small applications, I would say, where you would have traditionally you would have your content management system, which is a server, which is a software which is running on a server and is also serving the client code. So you have, for example, a PHP-based CMS where you have your administrators who added content, and then you have a website which your end users will see. And both the administrator dashboard as well as the website is served with the server-side code. This is like the traditional setup, and it would involve deployment efforts because you have to, for example, deploy a database and deploy the backend code. And there's this new trend where you would say, okay, maybe we should just serve the static HTML on a static file, static hoster, and have our backend servers available to administrators, and they can put in the data there, new content, and every time they do this, then the new website is produced, like it's built and then uploaded to your cheap static HTML hosting service, like, I don't know, Netlify, for example. And this has a lot of advantages. First of all, it's super fast because it's just HTML. And you would have from the backend, you would have a so-called well, the backend would be a so-called headless CMS. Headless because it doesn't serve the website, just an API. And you have your front-end code, which is then calling your headless CMS, your API. And there are even companies who give you all of this with batteries included. So there are companies like Contentful, for example, where you just log in as a developer and you basically click your API with buttons. Like we have a UI, and then you can click your schema and generate it, and you don't have to write any code for your backend, and it's just there, and you have your API to fetch data from, and you can give this the administration dashboard to your customers, and your customers can then, for example, put in content there. And the big advantage of this is that you don't have to worry about anything which is in this cloud anymore, because everything which is in the cloud here is provided by the service. So by service, I mean, for example, Contentful or GraphCMS and something like those headless CMS providers. And it's not your responsibility anymore. So you don't have to write any code at all, right? And then, of course, if you have a headless CMS which is exposing the GraphQL API, you have again have just one query, one complex query fetching all the data, and the data is coming from somewhere you don't even know. Probably it's saved in some SQL database, who knows? But it's all not your responsibility anymore. You can focus on the client code, and that's it. You don't have anything to, like, there's no code to write anymore. Does that make sense? Also think about like performance, think about maintainability and development costs. I will make a stop here. Oh, I didn't publish the last polling results. Are you okay with that so far? Does it make sense? Do you see the advantages? Yeah, there's one chat message. What about security and headless CMS? Can you maybe explain your questions a little bit more? Like, do you have an example in your mind? Are you talking about, for example, write access to this API? Exactly. Yes. Yeah, you're one step ahead. We're discussing this on the next slide. So they are asking, the question is about authentication and authorization. So you probably don't want stable examples. So you don't want to allow write access. Most of those CMSs have an option where you can say, I only want to allow read access, for example. Okay, that's one thing. But most of those headless CMS don't have a fine granular restriction. For example, I want to allow read access only on these fields, right? So it depends on your provider, but as to my experience so far, it's most of the time it's not satisfying how you can restrict access to the data, right? Most of the time, what I know is most of them allow you to say, okay, I want to have my data publicly accessible, and no one is allowed to write data without an API key, for example. But for most use cases, this is not enough. For a very simple use case, it might be enough. Can you hook it up with an identity provider and delegate permission handling to it? Maybe, but what you actually want is to have, if you're, for example, doing write access, you want to have programmatic access to the backend, and then you would give out an API token. So OAuth, I mean, yeah, everything is possible probably, but we're talking about a very, very, very simple use case here, where you maybe don't have or don't need authentication, right? You just say, okay, I'm having a static website, for example, and the client only reads from the data, and that's it. Then you can just say, oh, yeah, fine, write access is protected, read access is public. I don't care. If you have, for example, no user data in there, and the client is allowed to read any data which is available through the API. Yeah, but you're one step ahead, because on the next slide, we have this. And this is now the scenario number 1, which is in the homework. So what if if you want to have your own custom logic in front of remote API, right? Think about authentication, think about authorization. Maybe you want to do some data validations. Maybe you want to do, I don't know, send out emails when certain data is created. Everything which is like custom and it's not generic probably will not be provided by a headless CMS. Anything which is specific to your use case, you have to develop yourself. And here comes the idea of GraphQL schema delegation. The idea is that you put like a tiny bit of backend code, which is only like implementing the logic specific to your use case, and that is responsibility. And this server, which you develop your own, will forward the requests coming from the client to the GraphQL API if it's allowed to, right? So maybe think of a gatekeeper, yeah? So the client makes a request, and this server, for example, is checking if it's allowed to write this particular piece of data. It's maybe doing authentication and authorization logic, and then sends out the request to the headless CMS. You have an API key, which you generate here, and then you will put this API key in your deployed server, and then the server is allowed to do anything and can write any data, for example. And then you can put this to the public, right? So this is then the publicly available or publicly accessible server for your client. And it's one indirection more, because you have one more hop until you reach the GraphQL API. So you'll have a little bit of network overhead, but especially if you have a GraphQL API, then you can use schema delegation, and then you have at least just like a constant number of, you have one GraphQL request here and one GraphQL request here, so not too bad. The headless CMS runs in the cloud. Then the communication link between the Apollo server and the CMS will be just as slow as the one between the client and the Apollo server. No, because if you can deploy your server in the internet, and the server there has a much faster connection to other services on the internet than your client. Where your client is on a mobile device somewhere out there on 3G or whatever, and this is much slower, right? So this connection is still pretty fast. Maybe they don't live on the same server. That's correct, but at least it's probably a fast connection.
But to add to that, the Graph CMS we propose to use is running on in the internet, in the public internet, yes. But there are also open source solutions which you could host alongside. So you would increase the speed here. But as far as we know, there aren't that many that also support GraphQL. That's why.
That's an amazing side note. So there's, for example, an open source headless CMS called Strapi.js, which you can deploy yourself. So if you want, and if you're okay with the deployment costs, then you can just deploy your own headless CMS. And this makes sense, for example, from a data privacy perspective. If this is managed, then of course you have to put that in your data privacy statement, and then one more service where you share data with. If you deploy everything yourself, then you're responsible for it, and that's fine. So I have used Strapi.js. I'm happy with it. I already contributed to Strapi.js, and that's also possible. And then then both live maybe on the same machine, for example. Right? Does that make sense so far? So people are writing in the chat, which I like a lot. And you can see that you have one indirection more, but you get basically best of both worlds, right? So you have your CMS, which is like responsible for the generic part, like CRUD operations, create, read, update, delete your data, and it's all there. You don't have to worry about it anymore, and you don't have to implement that. And then you can just focus on your application code, right? You just need to write what is necessary for a specific use case. And for most use cases I have experience with, this is really, really small. Like maybe you want to, I don't know, implement something like a booking procedure, right? So you have a form where you can, I don't know, sign up for a seminar, and then this backend will allow this request and save the booking. And once that is completed, this service will, for example, send out a notification email. And the only thing that you have to worry about is to send the notification email, just as an example. And that's it, right? And then you're done, basically. Just deploy both of them and you're happy. And you don't have to worry about anything anymore. You don't have to, this is basically stateless. It doesn't have a database itself. That's all here. And you just deploy this, I don't know, on a serverless infrastructure, which is also really cheap. And that's it. So you have really to write a very tiny fraction of code, and it's only what is specific to your use case. So you get, best of both worlds. No one is writing into the chat, but thank you very much for the questions. And there's no more slide. I'm probably annoying right now, but yeah. No, you're not annoying, not at all. I love your questions. Do headless CMS provide some kind of service level agreements that guarantee high availability for our database? I would say that it very depends on the provider. I'm going to share my screen now. I'm going to close the chat and share my screen. And we have a look into the homework, because I have a listing of headless CMS there with all their features and subtleties. So no, this is not homework exercise 5. This is it, right? So this is what we were talking about now. And I have this comparison here. And this is like a list of a lot of different providers. Well, there are quite some few. So these are the headless CMS. And on the x-axis, you see a long list of features and a check mark if the provider is supporting it or not. And yeah, you can find a lot of there. And for example, as told you about Strapi JMS, which is self-hostable, open source piece of code. And what is important for the homework is that you move here until you go to GraphQL mutations. So many of them have a GraphQL API, but only few of them have write access or like supporting mutations. So you can order here, order again, and then you see those which have support for GraphQL mutations. And there are not so many. So there's Cosmic.js, there's GraphCMS. I do have experience with GraphCMS. There's Strapi, which is a self-hostable open source application, which is quite nice. And apparently also Unite CMS, which I also have no experience with. Which of them is, oh, that's interesting. This is also open source. Oh, nice, cool. And yeah, so it depends on what you want to do. You can decide to deploy everything you want to yourself, or you can use a managed service. And regarding the service level agreements, maybe they have it here somewhere. Wow. Okay. Maybe this is an exercise for you. Yeah. Which of those have an SDK? A role-based OAuth. Yeah. There we go. So there you can see which one has OAuth 2 support. There's a lot. A GDPR API. Interesting. Yeah. You can have a look. I hope this helps you or this answers the question. Can you give me some feedback if people are writing in the chat if that is satisfying for so far?
Looks like it, yes.
Great. Okay, so I hope this gives some context for you, how you can think about GraphQL. And so let's focus a little bit about on this scenario, this part of the homework now. And I told you, or this is it's linked in the exercise even, that I provided you with some demo code to make this exercise a little bit less challenging, right? I see that this exercise is very complex, but for both scenarios, I provided you with setup code, so you don't, you get a smooth start. And I also added this sentence here to mark this scenario as probably easier than this one. This one includes Neo.js, which is really interesting. But when you do this, you don't have to worry about Neo4j. You can forget about Neo4j or Neo4j driver or Neo.od and so on, or Neo4j GraphQL.js because you don't use it. So if you feel overwhelmed or whatever, then go for this. It's easier, I think. It's not uninteresting because it's as I said, a nice scenario where you have this use case. I want to write as little code as possible for my small full stack app. So it's not uninteresting. And yeah, so let's have a look into the demo code. I wrote this README here and explained what you have to do. And I want to do this right now so you can actually see this. I have used GraphCMS, which is like a German company, and I've used it because it's supporting mutations and it's managed, so I don't have to worry about deployment at all, which can sometimes be very, let me quickly check out my password manager. Like not needing to worry about deployment can help you a lot sometimes and make things easier. So I just logged in, and then you see like this dashboard, and you have like several applications here, and I called one of those applications like Hacker News because it's what we do in the lecture. And then you have this menu here, and these menu items are very, very important. So you have schema, and then you have content. Well, assets also interesting, and then you have an API playground. So let's have a look into schema first. This is a user interface, a GraphQL user interface where you don't write code, but you can click your schema. I created two collection types, person and post. You cannot use user because apparently the name user is a reserved keyword for GraphCMS. So I used the name person. And then you can, I don't know, add as many attributes as you want. You can, I don't know, you could, for example, what can we add here? I already added name, but why not add a role, for example? Do we have an enum here? I don't even know. Rich text? Well, we could, for example, add role, and then you have a field called role, and then you have like a few basic validations. Is it required unique, which comes from the provider itself. Everything else you have to like implement your own. And then you have a new attribute on your person model. Yeah, I thought it's an enum type actually. Oh, there, right. I'm so stupid. So let's delete this. Yes. Oh, I've deleted the wrong one. I'm messing it up. I wanted to delete that one, but no problem. So there's the drop down. You can create animations here. Okay, cool. Role. Enumeration values, admin, and moderator, user. Create enumeration. And then person, drop down, role. That's it. Great. And we have another collection type, which is called a post, which has just a title and some text, right? This is self-explanatory, I hope. And text is a rich text, so you can add like markup, but let's come to that later. When you have a collection type, you can then just click your reference. And you say, I want to have a post, and one person can write many posts. So you have a one-to-many relationship, and one post has always one author as the person. And then I can, for example, configure my reference. This is fine. So from the user perspective, you have posts, but if I have the reverse, I would call it the author, like this. And I'm done. Great. So now we have the author showing up here, and then I can write content. I already created two persons. You can see the name here, Bob and Alice. And
can you quickly explain here what the difference between draft and publish data is?
Oh yeah, that's a feature which is commonly seen in CMS. So you have stages, and you draft translates to Entwurf in German. And it means that your editors can write or add data and then decide later to publish it. So you have like a different subset of data. The published subset will be available to your end users on your website, for example, and the draft data is only available to, I don't know, editors. Or you can have, for example, a staging website under a different URL, which is what you see. Like the staging website would then get the data from the draft stage, and this is what you would see if you publish the data. Does it make sense? For us, it doesn't matter. Okay. I also have a post. Can you quickly say if that answers the question?
Yeah, it usually takes a second until the person is responding, but he just said yes, it's okay.
Nice. Cool. So I was clicking on one post, and I said, because I was like deleting this relationship, I'm going to say, yeah, author is now Bob. Save. So far, so good. So there's like schema, which is like describing the abstract schema of my backend. And then I have content where I can write like the actual content with a UI. That's what your editors would do. Since I added the role, like why not set this? Maybe Bob is a moderator, and I don't know, Alice is a admin. Save. Great. What I also get from this service now is I have a GraphQL API, right? So if I click on this, I can say, give me all the people and give me all their names. Boom. Nice. I can also say, give me all posts and their title. And then I can see that Bob wrote a post. This is the post which I just connected. I have other things like, I don't know, created ad or ID.
Maybe you can increase the size a little bit.
Oh, yes, sure. Is it better?
Yeah, it's better.
So here's my query, and this is the response. And you're familiar with that, aren't you? This is what you have on your Apollo Playground as well. So this provider is giving me a nice interface and GraphQL endpoints. So let's have this scenario in our mind, which we want to achieve, this one, right? So somehow we want to access this endpoint. This is like now GraphCMS with our own backend, right? So what we need is an endpoint and probably an API key, because we don't want to let everyone write data. We just want to allow this for our backend and for no one else. And GraphCMS has this included. So you have to click on settings, then you have API access, and here's your endpoint. And you can have permanent auth tokens, which is what you want. This is your API key, right? If you want, you can test the API key in this dropdown. So this is my token. This is as if I would make this request from my backend, and then you can check if you have sufficient permissions to do that.
Can you, in theory, if you have the sufficient permission, also mutate data in the playground?
Yes. You can write mutation, and let's see what we have. You can create person. You can say data, and then what do we have here? Name, and role, user. And then I want to get the name, the ID, role, created ad. Go, works, nice. So this ID is now generated by GraphCMS, and you can see it was just created. Awesome. So this is possible.
Okay,
so
cool.
Now let's go to our code. Yeah, so if you go to this demo code, which I provided, then you're on the branch demo. And there's a folder, homework/demo. This is also where the README is located. So you could just check out this branch, and there's like a fully working setup, which just needs your endpoint and your API key. And I added this tutorial or this work through here. So it's just describing what you have to do. And it's also describing, it's assuming a particular schema where you have posts and persons. And all you have to do is you have to put GraphCMS endpoint and GraphCMS API token in .env, and maybe store a JSON Web Token secret. I just checked out this, this branch, so I am on demo. Let's open my editor. And as I said, you need to put into .env your API tokens. So this is the endpoint which I copied from the dashboard, and this is the API key. By the way, also a JSON Web Token. And then the random JSON Web Token secret. It doesn't really matter. Great. And you can now use GraphQL schema delegation to connect your own code with the remote API endpoint. And this is like something brand new. I think the organization is called The Guild, and they just depublished a new refurbished API for schema delegation called schema stitching. It has been around for quite a while, but it was apparently buggy in the past. Now they refactored it a lot, and it has apparently become much better. And this is where you should go to. So GraphQL tools, schema delegation, and schema stitching. So I'm now clicking on schema stitching, and you can combine several schemas. And all you have to do is to get something which is called an executable schema. And then you can combine those two schemas, and they don't have to know each other. This is a perfect scenario if you have no control over the type definitions or the schema, which is the case for a remote schema, which is. So the GraphCMS schema here has no idea about my own schema, which I add on top of that. And it's my responsibility to wire those two schemas up. I can have so-called sub-schemas, which you can see here. Or I can add my own schema, which is extending in a sub-schema. We'll come to that later. So this is the documentation that you want to check out if you want to work on the homework scenario 1. How does it look like? I said I have this branch demo, and I have the schema here. and I'm using stitch schema. Where do we have it in this documentation? So this is what we have in the documentation, this method called stitch schema, which is coming from GraphQL tools stitch. This is the software library that we are using. So you would have to npm install the software library. And then you can import it in your code. And then you can use it. So instead of having one schema, which you plug into Apollo server, you have a multiple schemas, which you combine to a single schema. And this single schema is called gateway schema. And this gateway schema is put into your Apollo server. So we are exporting a function here, which is returning this gateway schema. So I have to look, where do I import this file here, the entire file? What do I do with this gateway schema? And I'm importing this gateway schema here, right? So this is our gateway schema, or this is the function which is returning the gateway schema. So what I do here is I say await schema, which is like, because it's an asynchronous function, then I have the schema and I put it into my Apollo server and then start the Apollo server. Right, so basically the same thing what you were doing earlier when you said type des resolvers. A schema is both combined. So schema has the type definitions and the resolvers. And in our case, it's the combined schema of one subschema and my additional type definitions and resolvers. Does that make sense so far? I should make a polling. I think this was complex.
There's one more question regarding with this not published, regarding this mutation in the playground and the GraphCMS interface. It changes the data on production, right?
Yes, exactly. So
if you want to have some kind of playground for development, you need a second project or something like that.
Yes, you can. So you have those stages, which also serving the purpose to give your editors something like a staging environment. But if you want to play around, for example, with the schema, you want to change the schema. This is not something you would do in production. If you want to do that, I would suggest to use a separate instance on, I think they're calling it application on GraphCMS. So a separate instance on their side. And so you get a different endpoint, and then you can play around with that. And then you have, you would just call the one development and the other one production or whatever. You can have as many instances as you want at GraphCMS. But yeah, that's a good question. All right, polling. Not too many people reply. Like only 11 people clicked yes. I'm always a little bit worried people cannot follow.
I think I also interrupted you in the middle, so I'm not sure whether all got the question. Sorry.
Yeah, it starts to get complex, so that's why I'm sometimes trying to get more feedback from the students. Okay, but at least 10 out of 11 people are happy. So let's go back to my code. So just have in mind, you have one schema which is composed of a number of subschemas, in this case just one, and my additional type definitions and resolvers, which know which are extending those type definitions which are in here. All right, so let's have a look. First, where does the GraphCMS schema come from? I'm going to this file, and this is what you see here. Here, we are using the GraphCMS API token and the GraphCMS endpoint. This is also copied from the documentation. It's exactly that. If you go to, I should close the chat. If you go to the documentation somewhere there, then it's explaining what you have to do. I think it's here. So you have your endpoint somewhere, and you get the type definitions from there. And this is like just a normal HTTP request. And so you have this executor thing, which is explaining how you want to communicate. So it's using this fetch, cross fetch. So this is just a library to make HTTP requests, which is making a post request to your endpoint. And it's also used to get the schema, like this, the type definitions. I don't know why they called this key schema, because it's actually the type definitions, which is being fetched when this starts. And then for every subsequent request, when the client is doing queries and mutations and so on, the same executor is being used. Yeah. So this remote executor is this function here. And it takes a GraphQL query, the variables, and then making the post request, right? It's just saying, yeah, here's my GraphQL query. And first of all, print this query, and then just send a JSON body with the query and the variables, and set content type to respond with JSON data, please. Right, just a normal post request. And then once you have that, this is of course an asynchronous piece of code. So you have to await this HTTP call. Then you have the response, and then you say, okay, parse the response as JSON data, and then this is what you have. So this fetch result here is basically what you see on the right side. This is JSON data, and it's being sent over the wire from the endpoint to your backend. And yeah, and you parse this as JSON data and make it available to your backend code. All right. So as I said, when the server starts, it has to fetch the endpoint first to get the type definitions there. If you have a remote schema, you don't have your type definitions in your own code. Yeah, so they are not checked into the repository. They live remotely. They live, in this case, a GraphCMS. Here we have our schema. This one, right? So this schema, you can make a GraphQL request actually to get the schema. I think it's something called like __ schema. Does it work? Okay, I have to, well, what's that? Okay, but you can say, I don't know what exactly is being called. Pretty, but yeah, so there we go. So you can make a GraphQL request to a GraphQL endpoint to get information about what's available. Right, somewhere here there's like my person things and so on. So you can, I was just asking for give me all types and their names. So this is what my backend is doing on server start. When I start my server, then now the request is made and it was successful, and my own server starts, right? So on server start, it's making this call. If I wouldn't have internet, for example, then my server would crash because it cannot live without the remote schema. All right. So that's about GraphCMS schema, and it's plugged in here. And what is nice is when I have the schema, I can put my own resolvers extending the existing schema. So these are my resolvers, and they know about the subschema. So they get the GraphCMS schema as like input. And my resolvers, I put them here. I think this looks familiar, right? So you had your type defs in your resolvers before. And yeah, those type defs and resolvers, they know about the type definitions in the schema, and they can call the subschema. That's the point here. You can have many additional subschemas, and they all totally independent. This doesn't know this schema and so on. But you can extend those subschemas with your own type definitions and your own resolvers. right? So you can basically add everything which is like missing. Permission layer, data validations, additional code, and you can do whatever you want. For example, here, I'm applying permissions to the gateway schema. You probably, those of you who use GraphQL Shield know what apply middleware does. And here's my schema, and there are my permissions. And I can just apply the middleware, which is nice, and return that final schema. So let's see how my type definitions look like. So my type definitions are, what's going on? My type definitions are here. And they're really, really small. All I do here is I have a query which is called profile, which is returning a person, and you don't see any type person here, you just see extend type person, but there's no type person defined here, which is like listing all those attributes, right? This is because the remote schema has the type person defined. And what I do here is just extend the type person. So these type definitions on their own wouldn't be valid. This is not a valid, this is like an incomplete type definitions. But since the type definitions are extending the existing ones, I can say something like, okay, profile, which is like the profile of the currently logged in person, and return the person here. I can also do this login logic, for example, and return a JSON web token. And I can do things like extending an existing type and add additional fields. For example, post count, which should represent the number of posts a person has written. So these are my own type definitions. And now let's go to our resolvers. I don't know what's wrong with my editor. Okay, now it's opening it. So here's my subschema. And I have to only implement the resolvers for the type definitions of my own. For example, login. Login is very, very simple. I just get the person ID from the args, and then I say sign the ID. So this is not a real log, like I'm not getting any password, I'm just getting generating the JSON web token for simplicity. Right? So this is a little bit silly, but well. And yeah, so I can start the server. I started it. It's running on localhost 4000. And what's nice now is that if I go here, I get all the queries that I have from the remote schema, right? So I can, for example, say people, name. Oh yeah, and there's one subtlety. So because we're talking about graph CMS, we have to provide those two arguments stay. Otherwise, I get this warning. Although, I mean, it's still, for some strange reason, it still works. If I omit this, I can say play, and it's still giving me data. But for some reason, I don't know what they have a strange way of requiring these two attributes. So they give out a warning when you don't provide the default locale and the stage. Draft includes, by the way, both draft and published data. So that's why I see those persons here. If I would say, give me only published data, then they are gone because they were all in draft stage. Yeah, fair enough. But you can see here that I'm calling localhost 4000, right? You can see that here. This is the endpoint, but my own backend code is calling the remote GraphQL endpoint in return, and I get my data back. But even nicer, I also have my own custom mutations. For example, login. This login doesn't exist on GraphCMS. So if I say here, mutation login, there's no login. But here, it is. I can say person ID. Oh, yeah, maybe I should get a person ID first. For example, Bob. Why not? Put that ID here, and boom, I have JSON web token. Awesome. So we can copy that.
Robert, I don't like to interrupt you, but we already spent an hour on this task, and I'm not sure whether the people got the concept. I hope so. We would have 30 more minutes for the other task. Somebody already asked for it. Maybe we can also ask, I'm curious, I'm not sure whether you have an overview, but I'm curious how many people try to use the graph CMS and how many are more favoring the second type. So yeah, so this is that. Maybe we can do an ask a question, how many people would like to continue here, or how many would like to let us go deeper into, let's make a poll maybe to ask where we should dive into more in the next 30 minutes.
No, it's fine. You're right. Thank you for making me notice. Like, we're spending a lot of time here. Some of the knowledge gathered here is also applicable on second task, but yeah, let's stop here. The only thing, I'm almost done. The only thing I wanted to show you is that I can augment my schema. I told you here's where I get my JSON Web Token, and I can put that as an authorization, and then I'm, for example, logged in as Bob, right? And the only thing that I have to do is I have to call delegate to schema, which is using my subschema. This is the graph schema, and I use the ID of the person from the context, right? It's the same as if I would do people, or actually person ID and that. Where? So I'm forwarding one of my resolvers are using delegate schema to forward request to the schema. And that's it, what I have to say regarding this. So this code here also has tests in place. If you want to be really quick with the homework, you know everything you need to know, and you can, I think this should be easy, right? Just basically extend the code and add your own tests and own resolvers, and that's it. Make sure that you put the API key. So let's focus on this one here. We had this talk about Neo4j and Neo4j GraphQL.js last time. And I found out 2 weeks ago that you can use the same technique here for you interacting with Neo4j GraphQL.js. Neo4j GraphQL.js is this JavaScript library, which is taking some type definitions and generating resolvers and additional top-level queries and mutations on top of that. I put this pull request here. So this is like the demo code, the same demo code which you have here for this scenario. That's the one here for this other scenario. These are the files changed. So it's adding a piece of code into this example folder, example schema stitching. And you can grab this code, it works. It also has tests, and you see them here. And it's using Neo4j GraphQL.js to persist data in a Neo4j database. So I'm currently now here. I am in, since this is a pull request of Neo4j GraphQL.js, I sent this pull request not somewhere in the homework repository, but into the repository of Neo4j GraphQL.js itself. And there we have the example. And this is like the folder which I added on my branch. In order to make it work, you must have a database, Neo4j database running. So when we have a look into the scenario here, this is not in the cloud or somewhere. It is on our own machine, like on our own server. We have to make sure the Neo4j database is up and running. And we have to write this here, like this code. Right? It's not somewhere on the internet. It's deployed locally. So in order to let a database run, I'm going to I'm going to say Docker run. I'm using Docker now to start the Neo4j database. It's the same command as on here. So you can also just copy paste that one. You can also install Neo4j locally according to the installation instructions if you have difficulties with Docker. If you have problems to set up Neo4j, tell us. That's always one of like the problems that students are facing. Like I cannot install the software. And yeah, once this database is up and running, it is available on localhost 7474. And there I have a web application which is connecting to my database. On first connect, I have to put my credentials here, Neo4j and Neo4j, and then I'm connected. And then I can start to write Cypher statements. So we learned Cypher in the last lecture. I can, for example, say match all nodes and return them, which is like give me everything I have in the database right now. Now, since my database is empty, I don't see anything, right? For this example, I provided some seeding. So if you're on the right folder, then you can say yarn run db seed, and it's like writing a piece of data into the database. Where am I? There we are. If I redo the same query again, this is now Cypher. I have some data. Like there's Bob, there's Alice. Alice has written 2 posts, and you have a relationship between this node to this node. And post just has a title, for example. And yeah, right? And let's maybe start from the Apollo playground. So I have my database, and I can say yarn run dev. And it's now available on localhost 4000. And now this is not connected with my remote GraphQL endpoint anymore, but with my Neo4j endpoint, with Neo4j GraphQL.js, I'm sorry. And so also the schema has changed. There's nothing like people anymore, but the query to get all items of type person is also just called person. Great. I don't have to put in stage or anything in here because it's a different schema. And still I have my persons. And where does that come from? Let's have a look into the code. Wow, sorry, wrong folder. So I am in the folder schema stitching, and I go to the source folder, and this here looks familiar, doesn't it? Right, I am using again stitch schema, which is this method coming from GraphQL tool stitch. And now it's not using the graph CMS schema, but a Neo4j schema. And this is now a sub-schema, and I put my own type definitions and resolvers on top. So where does Neo4j schema come from? Neo4j schema is now in this folder Neo4j GraphQL.js/schema. I go into this file, and this looks a little bit different. So first thing is I see a few type definitions, but I only see like type person and type post, nothing like type query or type mutation. And the type definitions are used as an input for a method called make-augmented-schema. Make-augmented-schema comes from Neo4j GraphQL.js. So this is a JavaScript library. And it takes the type definitions that you wrote yourself, and you have your fields, ID, name, for example, email, and then you have posts. And this post is, post will return an array of posts, and you have your type post declared here. And you connect them with a so-called schema directive. Schema directives are written with this @ symbol. And here you say @ relation, and you say, okay, a person has a lot of posts, and they are connected with a relationship called road, and it's going out. If you compare that with, where is it? There. So if you compare that with this graph visualization, you have a node, which represents the user. Then you have an edge, and it's directed at the post, right? So you can see, do you see this arrow symbol? Like it's going into that direction. And this relationship has the relationship label, I think it's called. I think it's for relationships, they call it type. So relationship type road. Make sense? That's what is called schema-driven development. So the whole philosophy of Neo4j GraphQL.js is you have your type definitions, and you put them into your Neo4j GraphQL.js, and then the magic happens, and then you end up with type-level queries, which are generated by Neo4j GraphQL.js. So only because you have type person, you get a top-level query for free, which has the same name as the type. You also get mutations. For example, create person, right? These type-level mutations are generated with Neo4j GraphQL.js. You don't have to implement them yourself anymore. Same with delete posts. So you have all the CRUD operations for your types. They come for free. And you can also connect the different types to each other. So you can, for example, add person to post or add person posts, right? These are generated type definitions and resolvers from Neo4j GraphQL.js. It depends on what you put in here as an input. So if you have another type whatever, you would get all the CRUD operations of whatever. You would have like the type query whatever, which gives you all whatevers. And you would have a mutation create whatever, update whatever, right? And so on. And for every relation, you get a mutation add something to another thing, right? Add person to post. This is also coming from Neo4j GraphQL.js. This is what is called type definition-driven development. So the idea is, I think the use case is you have a data scientist which doesn't want to write Cypher. He just wants to write a couple of GraphQL type definitions, and he wants to write as little code as possible. So this is great for a use case, like I would say an offline use case, where you don't have to worry about security or anything. Yeah, maybe I should make a stop here.
Yeah. Maybe everybody can think also about what their problem last time were, and whether Robert's words helped a little bit to resolve issues here. If not, feel free to write comments. I got a question. So basically, Neo4j GraphQL.js generates all the queries and mutations themselves. And what if you are not content with what it's generating? Say it's just the name you want to change, or even the logic. Then you would have to just use your own resolver, which you stitch together somehow there, and everything you write in there overrides basically what Neo4j GraphQL.js is generating.
Yes, that's an amazing question. So again, what if you want to customize things, right? And what if you're not happy with what you get? Neo4j GraphQL.js is making a tight coupling between type definitions and your resolvers and the auto-generated resolvers. You have very limited, as of now. I hope I'm not. I mean, I haven't really checked out the docs, I must admit, but as far as I know, a year ago, you have very limited configuration options, what generated resolvers you want to have and what not. So I think in the documentation, they specify, they have like schema directives for things you don't want to add as automated resolver. And at some point, you can also say, okay, I only want to get the query auto-generated, the queries, and not the mutations. I cannot find the configuration. Okay, I think I cannot find. No, defined. Yeah, so here we are. I just found it. So you have make executables, make augmented schema, which is returning an executable schema, and make augmented schema is taking options. And in options, you can say disable all queries, disable all mutations to be auto-generated. Yeah, so that's what you have. Yeah, so yeah, this would only generate your automatically generate your the queries. Here you can specify. There we go. You can specify a little bit more specifically what you want to allow and what not, right? But the naming has to match. So you cannot just rename those top-level queries, for example. The Neo4j GraphQL.js comes with a fixed set of like naming conventions, and yeah, you have to basically to live with that if you want to go that way. Otherwise, always possible, you can do everything yourself. If you want to have total freedom, 100% freedom, you just write your Apollo server and call Neo4j driver directly. And you have to write Cypher, of course. Does that answer the question, Yuri, for now?
Yeah. Mm-hmm.
Yeah, I also think this is a problem. This is a problem. This type coupling of type definitions and your resolvers is convenient, but also maybe not great for a use case if you want to develop a full stack web application. And that's why I was searching for other ways how you can get best of both worlds again, right? I want to get all the convenience of Neo4j GraphQL.js, but I want to do, like, I want to customize everything, right? And Neo4j GraphQL.js has one amazing advantage. It's only sending one data call. Even if you have a really complex query, for example, you have person, and I want to get all posts and their title, and I want to get from every post the author and the name again, all of that is just making one database call. Right? You don't have n+1. Even if it's getting more and more complex, it is just one database call. If you would do this yourself, you probably would make multiple database calls, and you would end up with n+1 between your backend code and the database layer, right? Does that make sense? Do you see what I mean? Actually, we can also, I don't know if it works, but there was this debug, Neo4j GraphQL.js, which will allow you to see the generated queries. Oh, sad. It doesn't. But you can log out the generated queries, and then you will see that for every request made to the backend, there's only one generated database call. Right. So it's performance-wise, this is best practice. Yeah. Neo4j GraphQL.js is doing all the logic to make a very complex database statement depending on your selection set here. Right? This is amazing. This is like a killer feature of Neo4j GraphQL.js, which you want. Because if you make it yourself and you make multiple database calls to get all the associated data, then you have multiple database calls, and with more complex queries, it's getting really slow. Does that make sense, Yuri?
Yeah. There are already some questions in the chat.
Mm-hmm.
So first of all, there's a suggestion that you can just run docker logs -f with the name of the container to see the logs. So if you want to do that. But apart from that, another question is, can you call the generated resolvers in your own resolvers?
So the first question, actually, I was the one who contributed this debug environment thing here. So I know that it's not, I will not see the logs, even in the Docker logs. Now I get it. I see what the person is talking about. Yeah, of course. I have to set this environment in the Docker container. Yeah, I'm stupid. Where's my Neo4j? Is it there? Yeah, of course. Second question was, can you repeat it again, please?
Can you call the generated resolvers in your own resolvers?
Yes. Do I have to do it like this? Just debug equals. You can. There's documentation for it. Is that probably? There's documentation of Neo4j GraphQL. The traditional way of doing it would be you have a function called Neo4j GraphQL, which is a JavaScript method, and it's taking the resolve info. This is the fourth argument, which is having the information about the selection set and so on. And you put all the arguments there, and it will make a database call and return the execution result, which has the resolved data. I was using this in a production app, and it is quite inflexible, I can say, right? Because you want to manipulate the database statement quite often. For example, if you want to add the author of a post to the database statement, then the author will probably come from your context, from the authentication information. And I found it very inflexible to use this method, even with the workarounds that they have also documented somewhere in this documentation. And I was super excited to learn about schema delegation, because with schema delegation, you can do it, right? So this is exactly, the question is actually mirroring the use case. Why I'm so excited about schema delegation. So since Neo4j GraphQL.js is its output is executable schema, we can just put it as a subschema and then pass that subschema to our own resolvers. And again, same thing. We have the subschema and we can delegate to this subschema. For example, when we do the profile. The profile is give me the person of the currently authenticated user. And all I have to do is to say, okay, I'm doing my custom logic, and then I'm calling the other, the query which was given to me by Neo4j GraphQL.js. In this case, the person query, and it takes as an argument the ID of the currently logged in person, and that's it. And because this info is the resolve info, the fourth argument of the resolver, can you see that? Right, so here's the info. I pass this info to delegate to schema. The info has information about this, what the client has put in the selection set. And if I, for example, say profile, I will probably get an authentication error. Interesting. Cannot read property ID of, no, nice. Yeah, but the selection set is encoded in this resolve info object. And anything I have in the selection, I can pass that to Neo4j GraphQL.js. This is especially helpful if you, for example, implement your write post mutation. So this is like a custom mutation, which I added in the type definitions, right? So we write post. It doesn't have an author as input here. So the author comes from the authentication context. And in my resolver, I'm writing the post myself. So this is creating the post. And then I call the query post with the post ID, which was generated. And everything the client has requested from the post, I have to refresh this. Oh, and it's a mutation, of course. Yeah. Title, whatever. and post doesn't have a name but a title, anything which is here, for example, the author, all of that is in the resolve info and gets passed to Neo4j GraphQL.js. So I'm like writing things first, getting the ID from the post here, and use that as an input to delegate to Schema. So in total, I have 2 database calls. That is one database call, which I have in my own custom code. And delegate to Schema will issue one more database call, but not n+1, just 2, which is totally acceptable.
Okay, so we get a couple of more questions, so we have to slowly come to an end. So what I understand here now is that you can basically extend the resolver with your own resolver, and in this, for instance, here in write post, you can call with delegate to Schema, and with the info, it can process the basic mutation you requested. So I hope this answers your question, Paula. Then there is another one. I'm not sure whether we can help with that, but some people are still having issues with the script git crypt. Do you have any idea of an alternative, Robert?
Yeah, so of course, there's an alternative. You send the API key to me via private message. If it just doesn't work, I have in the seminar last week, people complained, hey, I'm on Windows, git crypt is not really nice to install on Windows. And yeah, if anything happens, just send to me the API keys via direct message. All I want to, the educational purpose of this exercise was to never commit your credentials to version control, right? So that's like the moral message of the exercise 5. I don't want to use git crypt. I just want to give this mentality, like get familiar with this best practice, never commit credentials, not even in a private repository. And that's like the moral message here. If it just doesn't work with git crypt, find a solution or send it in. If nothing works, send it to me via direct message. Does that answer the question? I just want to try out your. I just want to try out your code. Basically, when I do the review, I want to start the server, and I want to connect with your. If you have a remote API, and I don't have access to your remote API, obviously.
I think it's clear that security is also effort, and you can think about yourself how you want to handle that. Either you find a solution to work with git crypt, or you install WSL, or you install a virtual machine for Ubuntu, whatever. But you can also just send the private keys or the API keys to Robert. Then there's still the request whether you can make a I use scenario 1 or 2 poll just for fun. People are interested in what other students are which scenario other students are using.
Oh yes, of course. Start a poll. So custom poll one. Let's call it remote GraphQL API, and the other one Neo4j / Neo4j GraphQL.js. Like this. So I don't, there's still people responding. Okay, I'm going to publish it. Here we are. We have 7 teams or 7 people working on a remote GraphQL API, and double of it, 14 on Neo4j GraphQL.js. Well, yeah.
Some apparently work on both.
Why? I mean, it's people, not teams. We have more than 23 students in our course, I think.
I don't know. Somebody just wrote in the chat both.
Yeah, I can see that people didn't respond at all, and I have a list of students who responded here, and yeah, so there are more people now listening. Yeah. Anyways, yeah, interesting. So the ratio is like 1 to 2. I think that's what we can say here. Yeah, it's the end of the lecture. I hope it gives you, all I want is to show you maybe an advanced feature of GraphQL, right? So schema delegation, schema stitching is certainly an advanced topic. So it's nothing you would face often, but I think it's extremely powerful and extremely versatile, because you can now, anything which, basically, first of all, anything which gives you a GraphQL endpoint, you can connect that to your own code. I want to give you one more example. I learned about a nice graph database called dgraph, for example. Super awesome. dgraph. It's a database, graph database written in Go, right? Which you can see here. It has 14,500 stars, which is a lot. It's open source, and it has a query language which was even inspired by GraphQL. And it's also, when you install this, it's giving you a GraphQL endpoint, which is available at, I think, localhost /8080 GraphQL. Yeah, so you have an admin interface, and there's a GraphQL endpoint at /GraphQL. So since you get an endpoint, you can use schema delegation to connect your database, basically, right? You would use it as the same as you would use a remote GraphQL API, which is amazing, I think. So you can, anything which has a GraphQL endpoint, you can now connect and put your own code in front of that. And Neo4j GraphQL.js is not even, it doesn't even have network overhead, because it's, in this case, it's even running in the same process, like it's running in the same Node.js process, so you don't lose any performance because there's no HTTP request made, right? So you can basically connect anything. You can go as complex as you want. You can even connect many different sources. You can have your data from your remote GraphQL API, or you can have part of your data living in a local database, or whatever. You can go as complex as you want, and can go indefinitely crazy and wrap schemas all over the way. So I thought this is nice for one assignment, and for the persistency assignment. We could have also introduced to you how to use a more traditional approach with data sources and, I don't know, calling an SQL database or whatever. There's so much GraphQL. It's like a whole universe of technology and different options, and there's many more things to discover. I hope you are as excited about it as I am. Do you have more questions? So it's 5 minutes past the end. Feel free to ask questions. I like that. You're not annoying me, not at all. I will have a look into the chat messages in the meantime. Okay, so writing a lot of suggestions into the chat.
Yeah, but it doesn't look like it. I think they're all clear, and more question can follow in the exercise.
Okay, then I would say let's call it a day, and I'm going to close the recording.